Good afternoon, everyone. Am I audible?
Yes, ma'am.
Okay. Slides are visible?
Yes, ma'am.
Okay. So we have reached to the last module of our course, and the topic that is left is the machine learning with Spark, and after that we have a small topic that is graphics library in the Spark. Okay, so we all know about machine learning. You all have studied the complete courses of the machine learning. So I just have a brief overview of the machine learning, and then we will continue with how we can use the machine learning libraries of Spark using the PySpark, or you can say using the Scala. Either use we can use the machine learning libraries of Spark along with the Python also, as well as the Scala also, and the various other programming APIs we know that if you are used to, so you just have to learn how to use it. So I'll show you the code examples like while processing the various, performing the various tasks, machine learning tasks with the Spark using Python and the code snippet for the Scala as well, right? So moving ahead with the machine learning with Spark, we know what is machine learning. In the current scenario, we are using most of the applications that we use today, they are machine learning applications. And according to the experts, 35% of the Amazon users and the 75% of the Netflix users, they are following the machine learning recommendations for performing most of their tasks. For while shopping on the Amazon, that means the output the recommendations which are being given by the Amazon, and for the Netflix, while we are watching the movies, the recommendations which are being given by the Netflix, like when you are clicking on watch more like this, whether it is the Amazon Prime or it is the Netflix, that means behind the scene, the machine learning algorithms have been used for generating all those recommendations which are seen in the form of more like this. Like, and in case of your Amazon also, when the products are recommended, so machine learning algorithms are being used over there. So when we are working with the Siri or the Cortana, you are giving your audio commands. So these AI assistants which are there performing the various tasks on your smartphone applications, basically the machine learning algorithms are working behind them. Then your machine translation systems, you have the Google Translator converting one language to the another, and just on a click you are able to understand whether if you're writing in English what we can call a particular sentence in Spanish or Russian or French language. Then when you are using the PayPal, using the machine learning is being used in order to identify whether there's some fraud has been happening or something is going wrong at the back end. So the machine learning algorithms are being used over there in order to detect the fraud. Then when you are using the search engine, like every day, that Google has become a part of our life. So while performing any kind of search, the machine learning algorithms are working behind the scene in order to find out the relevant results for you. Similarly, when you're taking the names of the friends on the Facebook, the machine learning algorithms are working over there. Then the self-driving cars, and you're searching for the photos, videos. You're you can say everywhere, whether it is a Gmail or recommendations of the or the various finding the friend suggestions which are there in the Facebook, right? So each and for each and every such applications, and you can say for the in the digital world, machine learning has become an integral part of each and every application. So what is machine learning? Basically, it is a process for extracting the patterns from your data using the various kinds of techniques, like they may be the statistical techniques or linear algebra or the numerical optimization techniques. So machine learning is in itself, it is not a technology. Basically, it is an amalgamation of the various techniques of the various technologies which are being used in order to derive the useful patterns in order to understand the behavior of the users, so that the businesses, they can design the new products and they can derive the new services in order to further gain the confidence or the trust of the to further establish the trust of the customers. So machine learning is, as I've shown you, the machine learning is widely being applied for the various kinds of applications like predictive power consumption, whether in order to do the classification task, identify whether a particular object is a cat or a dog or in a particular video, or clustering of in order to understand the structure of the data by performing the various clustering techniques, or to perform the in order to identify the outliers, where we say when we have to identify the detect the fraud, we do the clustering, and the outliers we say they are more, they are during the fraud detection process, outliers is the focus of our work. So the various kinds of machine learning algorithms, they exist in order to solve the various wide variety of problems. So machine learning algorithms, we say there are two terms that we use. One is machine learning algorithm and another is the machine learning model. So the machine learning algorithms are a part of the, or you can say they are used in the machine learning models in order to develop the models. So what we have in the complete model, what we did is the process of machine learning. It begins with the fetching of the data, reading the data, getting the data. And after that, in order to develop the model, we use the machine learning algorithm. So the machine learning, with the help of the machine learning algorithm, we design that particular model. What is a model is basic. Now, model is nothing but a mathematical function of the various parameters and the values. When we say y is equal to w naught x naught plus w1 x1 plus b, so here we can say if you just eliminate all other parameters and they say y is equal to w naught x naught plus b, it becomes a regression model, right? So the question of a line we say. So what is w naught? What is x naught w1? So x naught x1 x up to n, they are basically the characteristics or features of the data, and W naught, W1, Wn, they are basically the weights or the importance of that particular feature that is associated with that. On the basis of these, you can see the various weights which are being assigned or which are being associated with all these variables. This model helps in understanding the behavior of the data, or you can say for developing the model, and more the appropriate weights which are associated with better is the model and better are the prediction. So after understanding, after using this particular, developing this model with the help of a machine learning algorithm, we use this particular model for the prediction of the, you can say for making the predictions for the data where the labels are unknown. For where you can say when you want to predict the price of a house, if you have identified W naught value, so in that case, after giving the value of X naught, you know the value of W naught and you know the value of the bias. After that, if we know the value of X, we can predict the value of a house if we are talking about the developing a model for the prediction of the price of a house, that is a regression model. So for you can say for since there are multiple algorithms which can be used for developing the machine learning model, depending upon the kind of problem that we want to solve. So these algorithms have been, these machine learning algorithms, they have been categorized as a supervised machine learning algorithms, unsupervised learning, semi-supervised learning, and reinforcement learning. So the supervised learning algorithms basically depending upon the kind of data we have, kind of prediction we want to perform. So whether the data is a discrete target variable is continuous or it is discrete or categorical. So if you want to make the predictions and you're using the continuous data, so in that case you're going to perform the regression. That is, like one example is the prediction of a house, price of a house. So there we are going to predict the price value, so that is going to be continuous. But if we are using the categorical target variable, in that case, it is going to be a classification algorithm like decision tree, support vector machines like that. So you are going to do the prediction of a particular label, that is a discrete variable or a categorical variable, like we do, whether, let us say we want to predict whether the image is a cat or a dog. So we have two target variables. So it can be a binary classification problem or it can be a multi-class classification problem. Then we have unsupervised learning algorithms where the target variables are not available. So when the target variables are not variable, we have to derive the information from the data itself. So we do, what do? We have two options. One is we can do the clustering of the data and find out the various clusters. Such clustering algorithms are widely used for the customer segmentation. Like we want to find out, we want to segment the customers these marketing people in the organizations, they are trying to identify who all are customers. They are going to like like a particular product with a particular set of features. So let us say if we perform this market segmentation, by performing the clustering, we can identify the set of customers who will be liking a particular set of features. Similarly, we have the association mining algorithms which are used to perform the market basket analysis, which is used in the placement of the products in the various superstores. Like you must have seen that whenever you go to buy the milk, you see the bread and butter and all these bread, butter, milk, all these are kept together at one place. So basically, it is being observed there is an association that if a person is going to buy the bread and butter, there is a high liability he will buy the milk also. Or if the person is going to buy the milk, then there is a probability that he will buy the butter and milk. So there is a high probability. So this is a kind of association that has been studied. So this is called as a market basket analysis. So the placement strategy that if a particular person is going for the shopping, what all products should be placed together in one location. So such kind of analysis is being done using the association mining, where we don't have the target, if we don't have the target variable available. So what these kind of algorithms are used to perform the various tasks or perform the and develop the various kinds of applications. Then we have semi-supervised learning. So there we have a categorical target variable. So we have two options over there when we have the semi-supervised learning, that we perform the classification, like we go for the text classification, and another kind of task that we perform, that is the clustering, that is finding the lane finding on the GPS data. So we don't have complete information available over there. Then we have the reinforcement learning, where we have the categorical target variable, and another can be the target variable is not available. So in the reinforcement learning, it is a gaming-like strategy that we are learning by itself. So whenever we do some task, it is based on the penalty mechanism. So if you reward and penalty mechanism. So if you do the task correctly, you will be getting one reward, and if you do it wrongly, there will be some penalty. A penalty may be that you don't get a reward. So for such kind of task, the learning is by itself, which we do basically when, like we can say that when small child is made to learn to walk. So in that case, if the child takes few steps, we give the chocolate to the baby. So that means he is learning. That means he is going right. So if he don't take the steps, we will not get the chocolate. So the child is learning by itself, that if the child takes the correct steps, walks for a few steps, then she is going to get a reward. Otherwise, no reward. So such kind of strategies, like all the game playing algorithms that you do, whether you're playing the game of the PUBG, or you do play the various games in the PlayStations. So all these are many of these are being used using the reinforcement learning techniques. Along with that, the driverless cars, basically, they are also, for the driverless cars also, the reinforcement learning algorithm is being used in order, because they are driverless, so they have to keep on learning their environment. So if they are taking the right steps, they are getting some rewards, otherwise penalty. So on the basis of that, the algorithm keeps on learning, and that over a period of time, the performance of these cars keep on improving. So these are the various kinds of algorithms, machine learning algorithms, which are being used widely for solving the various kinds of problems in the real world. So you can see this is an example of the supervised learning. So in the supervised machine learning, we say your data consists of a set of input records which have the associated labels, and the goal is to predict the output level for a given new labeled input. So they can be either discrete or continuous, as we have already discussed, and the classification may be binary classification, where we have to just two labels, either a cat or a dog, and it may be a multinomial classification, so where we have the multiple labels like Australian Shepherd, Golden Retriever, or a Poodle. Right? So we can have any kind of such classification problem. So the various popular classification and the regression algorithms that which are available, they are the linear regression, logistic regression, decision trees, gradient boosted trees, random forest, naive Bayes, support vector machines. So you can say using the decision trees. So you can say linear regression is totally meant for the linear regression only. Logistic regression, it is for the classification. Decision trees, gradient boosted trees, and random forest, they can be used for both the task, and name base and the support vector machines, they can only be used for the classification. Then we have the unsupervised. As I said, the unsupervised, we don't have the target variables available. So these unsupervised machine learning algorithms, they play a very they play a very important role when we don't have the target variables. So instead of predicting the label, we use these algorithms in order to understand the structure of the data, and then based on the structure of the data, we because there are large number of applications where when we apply these algorithms, we are able to better understand the markets. Like for the market segmentation, we are segmenting the customers. So the thing is, in order to apply this machine, in order to develop this machine learning algorithms, so since the size of the data is increasing day by day, and we are talking about the big data these days, the Spark has provided the machine learning libraries in order to perform the same machine learning task for the large amount of data at a faster pace. As we know, Spark is 100 times faster than MapReduce for over the disk, and 10 times fast. Sorry, 100 times faster on the RAM and the 10 times faster on the disk. So we can perform. Spark provides a unified analytics engine. And it provides basically an ecosystem for the data ingestion, feature engineering, model training, and development. That means all the machine learning tasks, it provides a complete ecosystem. So if we see what is the difference is when we are not using the Spark, we need to do all the various tasks. For performing all these tasks, we use the different tools to accomplish this task, and we have to struggle with the scalability. But once we have a complete ecosystem, so in that case, we can create the complete pipelines in order to perform the various tasks, and we can do at a very, you can say, that we are able to improve the scalability and do the task at a faster pace. So basically, in Spark, we have two machine learning packages. One is Spark.ml and the Spark.ml. Spark.ml was the original machine learning API that was based on the RDDP API. So, but now it has this is in the maintenance mode since Spark 2.0. So the current machine learning package that is being used, that is called as Spark.ml, and this API is based on the data frames, which is widely being used in the current scenario. So with the Spark.ml, all the data scientists, they can use one ecosystem for their data preparation as well as for the data modeling, and they need not do any kind of downsampling of their data to fit onto a single machine. That means you need not you must have seen in the various in your major project also. So you're struggling to deal with a large amount of data, and you have to do the downsampling in order to develop the machine learning model. So when we are using the Spark.ml, you need not do that particular task. So your ML, it focuses on O of n scale out. So where the model will be scaling linearly with the number of data points as you have. So you can, that means this Spark.ml, this particular machine learning package, it can scale to massive amount of data that you have been struggling with the other libraries like your scikit-learn or any other machine learning library that you have been using. So in the machine learning, when we have to work with this particular library, see MLLRV, this is no name, this is just, there is no specific, this is not some formal name. So this is just used in order to indicate that we are using the machine learning library. So these days, whenever there is most of the organizations, they are developing the frameworks, and the concept of pipeline is being used. So pipeline basically is a kind of framework that provides a mechanism to organize a series of operations to apply to your data. So by developing the pipeline, these operations will be performed, performed by themselves. On all these operations will be performed in that particular order, and then you don't have to do the to apply the various operations in chunks as you do with the other libraries. So it is basically this pipeline API is a high level API that is built on top of the data frames. So in order to perform design the machine learning workflow. So it is basically composed of series of transformers and estimators. So what is a transformer? Basically, your transformer, it accepts the data frame as input and returns a new data frame with one or more columns appended to it. And they do not learn. Basically, the role of transformer is nothing. They are not going to do any kind of learning of the parameters from the data, but they apply the rule-based transformations to either prepare the data for the model training or generate predictions using a trained your machine learning model. So here for performing these transformations, dot transform method is being used. Then we have the estimators. So basically estimator is the one that learns the parameters from the data frames, or we're using the dot fit method, and returns a model which is a transformer. Basically, if you can recall, all of you must have used a Python. In the Python, you have used the machine learning libraries, and there this particular method is being used, the fit method. So when we apply the, so you can say this is basically the complete method that is used to train the model, right? So developing the model using the fit method. So that is called as the estimator over here. Then we have, as we discussed, the pipeline. So it basically organizes a series of transformers and the estimators into a single model. So pipelines, they themselves are the estimators. The mod output of the pipeline is dot fit returns a pipeline model that is basically an transformer itself. So we will see the code further. So let us do the data ingestion and the exploration using the machine learning package. So the first task that we have to do is data reading. We know what to do. So in the Python code, so I've shown you over here is the Python as well as the Scala code. So in the Python code, when we are using the machine learning, when we are doing this particular task, so we write file path. So we after specifying the path, what we are doing is we have to see you can we have done we have used a Spark context as I've shown you. So Spark dot read dot file format we use. Here we have used a Parquet file format, or you can directly use a Spark context dot file text file. So as I've shown you the various examples when we were discussing the various other applications, the usage of the RDD and the data frames, we have seen how do we read the data. So here we are just performing that particular task, and from there what we are doing, Airbnb is basically this is nothing. This is just a variable name, and DF is stands for the data frame. So Airbnb. So because this particular task has been performed for the Airbnb database. This is the name of the database that is being used for the this is basically the renting of the houses, right? So when the people have to go, you can say it is like a online platform where the people are which is being used to provide houses on rent. So that particular data has been downloaded over here. So and the various uh, features which are being used, or the various attributes of that data that are being used are neighborhood is clean, room type, bedrooms, bathrooms, number of reviews, price, like that. So these are the you can say 4 or 5 features which are there in this particular data. And what we are doing, we are Airbnb. So we have first read the data from here. Out of the there in this particular data set, we have multiple features, multiple attributes, but here we are showing only the 5 of them. So just to understand the data. So what we have done, we are ingesting the data and we are exploring. So we are reading the data and then we are exploring. We just want to see what is there in that particular data. And as you can see, the table it is showing showing the output of this particular table, what kind of information is there. And similarly, we have done the same task using the Scala API. Now, In order to develop the machine learning model, what do we do? We create the training and the test data set. So what do we do? So for see, in order to understand the whether the model that we are going to develop, what is the accuracy of that particular model? So since if we are not aware of the accuracy of that particular model, we cannot use that particular model in the real time. See, if there are, see, let's say if we use a model for the market segmentation, it may be that the model is not correct, and we have segmented the market wrongly, and based on that, we have launched the product to a particular segment which was not at all interested in that particular. So in that case, the company is going to incur lots of losses. So in order to understand that whether the task that is being used, that is being done properly or not, what do we do? See, we cannot do the testing in the real world. So for that particular sake, we divide the existing data that we have into the training and the test data. We use the training data for developing the model. Here you can see the capital X represents the data that is used for training. So where we have n by d, n is the number of rows, d is the number of dimensions, and then we have the y for the labels of these matrix data that is represented using the n by n cross d matrix, and cross 1, which is basically a number of rows of one dimension each. So these are basically the target variables that are. So what do? We apply the machine learning algorithms over here, develop the model, and after that we compute the accuracy of this model using the test data set, which is also of the similar kind of dimensions. And then once we have understood what is the accuracy of the model, accuracy is an evaluation matrix. So where we use this particular model in order to make the predictions for the new entities. So this is basically the goal behind creation of the training and the test data. So here in this particular case, let's say our goal is to predict the price per night for a rental property based on the given features. Since we are going to predict the price is a continuous value, so we are going to develop a regression model over here. So what do we do? How we are going to do this particular split? We know most of you, I know you have done this particular task in the Python. So trained data frame, test data frame is equal to Airbnb df. As we have loaded this particular data in the previous slide, Airbnb df, it has a file, right? So our data is stored in the form of data frame, that is in the form of rows and columns, right? So what do? We use the random split method in order to split the data into the training and test data, that is in the ratio of 80 and 20%. So 80% of the data will be used for the training and 20% of the data will be used for the test data set. And then we are just printing there are train df.count rows in the training set and test df.count in the test data set. That means we just want to know what is the number of rows in the training data set and what is the number of rows in the test data set. And you can see the output is there are 5,780 rows in the training data set and 1366 in the test data set. So after the split, the amount of data which will be used for the training as well as for the testing. Now we have to prepare the features with the transformers. So what do? So we have to prepare the data. Now you see here what we have done. We have prepared the data so that we are able to apply the model. And before the applying the model, we have divided the data into training and the test data set. So now to prepare the data to build the regression model predicting price given the number of bedrooms. So the linear regression basically requires that all input features are contained within a single vector in the data frame. So in order to convert this whole data into a single vector in the data frame, we need to perform the transformations. So transformers in Spark, they accept the data frame as input and return a new data frame with one or more columns appended to it. So since the first data frame that we have created, that is in the form of a matrix, now we are going to convert it into a single vector, right? So a row vector by applying the transformation. So now they do not learn from your data, but apply the rule-based transformation using the transform method. So we are not going to do any learning. We are just converting the data into a form so that we are able to apply the linear regression model. So to put all the features into a single vector, we are going to use vector assembler transformer. So the vector assembler transformer, it will take a list of input columns and create a new data frame with an additional column, which we will call features. So here you can see from pyspark.ml.features, here you can see, since in the Python, the Python library of Spark is PySpark, and in the Scala, we are using org.apache.spark.ml, right? So there is a difference, in the syntax that we use. So, but the library that we are using is for the transformation is the vector assembler only. So, vec assembler is equal to vector assembler, and in the Python, what we are doing? So, we are just passing the parameters. Input column is equal to bedrooms, comma output column is the features, and then we are applying vec assembler dot transform. So vec train df is equal to, so again see we are creating a new data frame, and we are applying the transformation over the train df, right? So train df, here we have train df over here on the training data, right? So we are applying that particular transformation. So finally what we are able to get is, so we are just printing that particular data. So here we have select bedrooms features price dot show. So you can see for the bedrooms and the various features which are being used, so the feature that is being used over there, and on the basis of that, along with that, what is the price of that. So similarly, here you can see we are only using these methods, the vector assembler methods, and we are passing these parameters as the features. But in Scala, we have to use the setter methods like dot set input columns, dot set output columns. So this is the difference between between the usage of the Python API and the Scala API. Now, once we have transformed the data using the transformation transform, so after the data is required and transformed into a format that is required for the linear regression. Now, basically in Spark, we say that linear regression is a type of estimator. It takes a data frame and returns a model. So since we have created a data frame over there, so we will be giving this data frame as input to the linear regression, and then it will be returning a model. So what do the estimators do? They learn the parameters from the data and have an estimator named dot fit method, and they are eagerly evaluated. This is the difference between the transformations and the estimators. Your estimators, they are eagerly evaluated, whereas the transformers, they are lazily evaluated. And the other estimators. So all the algorithms, I'll say, so in order to simplify the things, I'll say all the algorithms that are you are going to use for developing the various kinds of models, they are basically the estimators in the Spark machine learning library. So from PySpark.ml.regression, import linear regression. So LR is equal to linear regression. The feature column is features, so the various features which are being going to use, and the label column is price. So on the basis of these features, we are going to predict the price, and LR model is equal to LR.fit, and in the bracket we have passed that feature vector, that is vec_train_df. If you can remember the name where we have created vec_train_df from by applying the transformation method of the vector assembler. So we are applying the estimator on vec_train_df, this is, which is a data frame, and it is taking the data frame as input and then giving us a model as the output. So you can say this LR.fit, it is a linear regression, which is a transformator, and the output of an estimator's fit method is a transformator. Now we are going to use the estimators to build the model. So here you can see M is equal to round LR model dot coefficients 0, 2. B is equal to round coefficient LR model dot intercept, right? And then we are just going to print the value of that. So here you can see this print the formula for the linear regression line is price 123 into 68 into bedrooms plus this. So whenever if you apply the value of the bedroom over here, you will be able to predict the price of this. So we are able to develop the estimate. We have used the you can say we have developed the linear regression model in order to predict the price of a house using the machine learning API of Spark. Then how to create a pipeline. Now we are going to perform the same task via the pipeline. So if we want to apply our model to our test data set, then we need to prepare the data in the same way. So see, by this time we have prepared the data for the training data, right? We have prepared the model for the training data, and for doing the same task for the test data set, we have to follow all those steps. So that means these data preparation pipelines, they will have the multiple steps, and it becomes cumbersome to remember not only which step to apply, but also the ordering of the steps. So this is the motivation behind the pipeline API, that you create a pipeline and all the steps will be performed by themselves. So you simply have to specify the stages you want your data to pass through in order, and Spark takes care of the processing for you. So it provides better reusability and the organization. So in Spark, pipelines are the estimators, and the pipeline models or fitted models, they are basically the transformers. So from PySpark.ml import pipeline. Pipeline is equal to pipeline stages. Here you say what stages we have. The two tasks were performed. Here we are specifying the stages equal to vect assembler, comma LR, right? And pipeline model is equal to pipeline.fit train df, right? So now we have created a pipeline for the training data over here. So another advantage of using a pipeline API is that it determines which stages are estimators or transformers. So you don't have to worry about specifying the name dot fit versus name dot transform. Here you can see we have used the fit only. We have not used the transformer over here. That transformer task we have specified vect assembler. So since pipeline model is a transformer, it's straightway applied onto our test data set. So prediction DF is equal to pipeline model dot transform on the test DF, and predict dot select bedroom features price prediction show. So here you can see for the complete data that we have taken on based on only the one feature, that is bedroom. So we have not used other features over here. The price of house is being predicted over here. So this is how we are predicting the price of a house for the test data. Now evaluating the models, we know we use the various evaluation measures. So for the regression model, we have used the root mean square error or the R square to evaluate the model's performance. I'm going to show you for the root mean square error. So from PySpark model in the dot evaluation, import regression evaluator. So regression evaluator is equal to regression, prediction column is equal to prediction, label column is price, metric name is root mean square error, RMSI. RMSE is equal to regression evaluator dot evaluate predict DF. So prediction DF that we have created earlier, the pipeline model, and we are going to print the value of RMSE, which comes out to be 220. So since you have been working with a machine learning algorithm, you should know about the root mean square error and how do we interpret this particular value. And finally, since we have developed the model, so we would like to save it to the persistent storage, so that if any of our cluster goes down, we need to redo the task, right? So we can reuse the model that we have developed, right? So here you can see the method to save this particular model is pipeline path is equal to, we are specifying just a path where the model should be saved. So, and pipeline model dot write dot override dot save pipeline path. So we are going to save this particular model in the specified path, and it is going to override that particular model if it already exists, and it is going to save that particular model, and later on you can reuse this particular model for making any kind of predictions for the unknown data. So this is how we use the Spark machine learning libraries, that is spark.ml, in order to develop the machine learning models. The way we have developed machine learning regression models, similarly you can do it for, you can see by using the different, instead of you can say the regressor estimator, you can use the other estimators or decision tree estimator and the various other estimators which are available in the spark.ml library, and you can develop the task and using the or solve the various kinds of problems which can which can help us in improving the performance of our application. So that's all with your machine learning with Spark. How do we do that? And we have seen how we can develop the machine learning models using the Spark API and using the pipeline. So attend your roll calls.